Okay, good morning. Welcome to
FunMath number 116.
FunMath number 116. Today we are taking a look at section 5.5. Okay, section 5.5 of Art of Problem Solving's Algebra book, and it's actually about linear equations in disguise. So we're going to learn sometimes when we can apply our ideas about linear equations. So say we come across this problem. Square root of x minus square root of y equals minus 1. 2x plus 3, 2 times the square root of x plus 3 times the square root of y equals 23. What does that make you think of?
The linear equation, except that the square roots on it. So
Right, this looks a lot like a system of linear equations. It's just that the square roots are not linear.
So you have to make a little substitution.
Okay.
You can say the square root of x equals a.
Alright.
And the square root of y equals b.
Alright, square root of x equals a, square root of y equals b. Tell you what, let's write those the substitution up there so you give yourself a little bit of room to work.
Square root of x equals a.
And just keep writing in a straight line over there. Right there. Square root of y
Square root of y
equals b. Okay, there you go. And so what does that substitution do to our equations?
It makes it a linear equation.
Alright, what are the equations now?
They're a minus b equals minus 1.
Okay.
And 2a plus 3b equals 23.
Okay, so what are you going to do?
So, we'd like to get the a's and we'd like to get one of the variables the same in both equations.
Okay.
So let's multiply this one by 2.
Alright. Good job. Step over there a little bit.
Write it down here.
Yeah, write it down there.
2a minus 2b equals minus 2.
Alright, what are you going to do now?
And I can subtract them this way. So 3b minus 2b is 5b. Is 23 plus 2, 25. B equals 5.
What happened to the a's? I mean, you didn't say anything about the a's.
Yeah,
What happened to them?
they disappeared.
They disappeared because you subtracted. We took 2a minus 2a, 3b minus 2b, and 23 minus 2. So we got b equals 5. Oh, that's nice.
Now we can plug that in here. And we get 2a minus 10 equals minus 2. 2a equals 8. A equals 4.
Ah, okay, great. So actually we've solved now for what a and b are. So what does that tell us?
Well, it tells us that 4 equals the square root of x. So 16 equals x.
Okay.
And the square root of y equals 5. So y equals 25.
Okay, now let's just see. Give me your pen. So we found that x equals 16 and y equals 25. Our substitution turned a very complicated looking equation into an easier equation, or set of equations, which we solved. Now let's put it into our original equation and see if this is true.
We're going to get
4 minus 5 equals
minus 1.
Okay, so the square root of x is 4 and the square root of y is 5. So we get, now on this one we get 2 times 4, so 8 plus 3 times 5, which is
15.
So what is 8 plus 15?
It is 23.
23! Okay, so this is actually a very useful technique to learn, substitution. And it can turn equations that don't seem like they're linear equations into linear equations, so we can solve them, get a nice solution, and then go back all the way to the beginning. The only thing we probably should have checked is that our solution here to this equation, a minus b equals minus 1 and 2a plus 3b equals 23, we probably should have checked that 4 and 5 actually solve this, because if we get over here and it turns out it doesn't work, and then it's a little bit harder to figure out where the mistake is. Okay, so that's the only improvement, is check the easy equation first. Okay, just to make sure there's no mistakes. So completely solve the easy equation, check it, and then go over to the harder equation. Okay, good job. Good morning. Would you mind erasing the board for me?